whiteboard. There it is. All right, 29. They're talking about transformations here. And if you remember, when we talked about transformations, we said, hey, what happens to the x, right, is it's going to be stretch or compression, right? If it happens to the whole function, then it's going to be stretch or compression of the function. So vertical stretch, right? So if it's to just the x, it's a horizontal stretch. To the whole function, it's a vertical, right? So if we think about this, this is really x to the 1/2, right? So this is really 3x to the 1/2. It's happening to the x, right? So therefore, this is and it's bigger than 1, right? So it's bigger than 1, so it's not a compression, it's a stretch. So it's what we call a non-vertical. Horizontal stretch of a factor of 3. Okay? So they're going to take this normal function, the square root function, remember it looks like this, right? And they're going to stretch it, and so it's going to look more like this. They're just pulling on it. Okay? All right. Number 30. We're going to talk about sine, cosine, amplitude. Okay? So remember, all right, so technically, we weren't going to do this until after the midterm, right? But because you're all graduating and stuff, so I don't know if we're going to get to it. So, this is what we were going to get to after the midterm, and then, yeah. So we were going to talk about trig identities and how to graph these SOHCAHTOA functions. All right, so sine, cosine, we should know is a 1, because we did it last year, now it's over 2. Right? And then there's a pi, right? And this is 2 pi, right? And a basic period for a sine function of a basic sine function means that it starts here, goes up to here at 1/2 pi, right? Goes through here, comes down to here at 3 pi over 2, and then comes back to here. So it looks like this. Up, down, and back up. Okay? And that's the sine function. Does that make sense? Okay? Now, this tells us what's happening to the period and what's happening to the amplitude. The A function right here is telling us that the amplitude is now 2. So now this amplitude just got changed to a 2. I'm going to move this down a little. Let me erase that really quick. Just so I can keep it on the same, so you guys can see it as on the same line. So we're going to call this 1 and 2, and 1 and 2. Okay, and this is still going to be pi. In fact, if I keep these like this, let's go 1, 2, 3, 4. Well, what I do is call this 2 pi and pi. And so then what I have is this is going to go up, down, and back up, right? So that's a basic sine function that's going through that point right there, okay? And then what's going to happen now is it's going to be stretched, and now it's going to be at, it's going to, not start there, sorry, it still starts here. But at this point, maybe it should go to here, right? But that depends on what our period looks like. In this case, our period is 2 pi divided by b. So if this were 1, it'd be 2 pi still. But in this case, it is 4. So now our period just changed from 2 pi to pi over 2. So what's going to happen there is this whole thing is going to stop at 1/2 pi, that means it stops right freaking there. So what I'm going to do is change it one more time. Okay, we're going to call this pi. Okay, we're going to call this 1. That means this is, 2 pi, and then this is pi. Okay? And what's going to happen is this is 1 and this is 2. And so at 1/2 pi, we're going to be at 1. Then we're going to go through here, here, and here. So it's going to go just like this. Okay? That's a typical sine, right? Typical sine function. Make it all look nice and neat, okay? All right, so then what's going to happen is our period gets changed to 1/2 pi. That means right here at 1/2 pi, that's going to be our end. Okay? So it only goes from here to here. Right? Now, our height, or our amplitude, is going to be 2. So that means that this is our end. That means this is our middle. Right? That means it's going to go all the way up here halfway through, all the way down here halfway through. So it's going to go up, down, back up. Right? And it'll do that how many times before we get to 2 pi? 1, 2, 3, 4. So technically, in the same thing, it would look like this. Right? Hold on. Something like that. Does that make sense? Okay. So that's problem number 30. So we took this and changed its amplitude, stretched it up, and then also compressed it. Cool? All right. 31. Oh, goodness. Do I have time? How much time's left? 7 minutes?
That's just dividing, right?
Huh?
Dividing?
Yeah! This is just, I like to call it synthetic division, but synthetic division, you do it without. This is called long division. So basically we think how many x's are in x to the 4th, and it's x cubed, right? So x cubed times x is x to the 4th. X cubed times 3 is 3x cubed. Draw the line and change the sign. Thank you. Useful for something. I know you hate it, but that's okay. So, that goes away. This goes away, right? And so then we bring this down. Well, we can't do that with this. So that nothing goes there. We have to bring 2 of them down, right? 19x. And then we say, well, how many x's are in x squared? 1. And then how many x's are in 8x squared? 8x, right? So it's going to go 8x times x is 8x squared. 8x times 3 is 24, right? X. Okay? And then I draw the line in, change the signs, and those cancel. Now this becomes negative, right? Negative what? 5x. Okay? And then I bring this down and it's minus 27. So I say, okay, how many x's are there? 5?
Hold on just a second. I love how you answer this like I'm at the front desk.
What's up?
Actually, he's teaching, so.
So 5 times x, oh wait, it's going to be negative 5, right? Because it's negative 5 times x, because we want them to be the same, right? And negative 5 times 3 is minus 15. And then we what? Draw the line, change the signs. That causes those guys to go away. This becomes a 12? So negative 12. Right? And so what happens here is it's minus 12 over x plus 3. And that's your answer.
Stormy wants to know if she can take her test tomorrow and stay in Catherine's today.
Yes.
He says yes.
Okay, this last one, real quick, then we're done for today. All right, we want to make these in terms of 4, right? In terms of 4. So when I think of 64, I think of 4 what?
Root
4 cubed, right? So this is really 4 cubed is equal to 4 to the 3a, right? Now once the bases are the same, then these two are equal, right? So then it's just 3a equals 3. So I divide. So a equals 1. And you're done, hon. Bow.
Oh, I brought down the
What?